Right, hello everybody. So this week's video is on the subject of function binding, as it's often called. I'll also add that it's often inaccurately called currying. Currying is very much a thing, and it's sort of related to function binding, but it's not a strictly accurate use of the term. Currying, amusingly, was named after a important mathematician. Possibly you'd call him a computer scientist in some senses, because a lot of his work is connected with computing, but I don't think he ever considered himself that. A man called Haskell Brooks Curry, who is, in some senses, I think, unique in that he has 3 computer programming languages named after him, one after each of his names. He's a computer programming language called Haskell, another called Brook, and another called Curry that are all named after him. So clearly he is quite important in the history of computer programming and computer science, whether he called himself one or not. So the idea of function binding, which is what we're going to be talking about and is not currying, is the idea of taking one function which has one signature and making it have a different signature. So let me just be a bit clear. I'm going to do this in Python. And Python is in some senses a slightly odd language to do this in, because Python actually gives you quite a few ways to do some of this, but we're going to talk about one way. And I'm going to define a function in Python. So it's going to be fairly simple, but I need a library. So it's going to be called wait and print, and it takes 2 parameters, which is wait for and message. Okay. And it's going to do time.sleep wait for, so it's going to wait for as long as we say, and it's then going to print the message. There we go. Wait for 2 seconds and print hello world. Okay, there we go. 1, 2, I count too quickly, but there we go. So it waits 2 seconds and prints hello world. And that's fine, that's a function, you're familiar with that. But the question is, what about if you need this function somewhere else in your program? Somewhere further down your program, you've got a situation where you want to say, I want you to wait for so long and then print a message. Well, that's fine. One of the things that you can do in Python is you can pass a function to another function. So, okay. So call a function and call fn with function to hello world. And I can now call caller with wait print. And that's waiting 2 seconds again and printing hello world. Okay, and that's fine. That's an example of what's often called a callback function. So I am passing one function, I'm passing this wait and print function into another function, this caller function. And callbacks are very common in computer programming. They are used all over the place. Particularly commonly used when you're writing code for dealing with graphical user interfaces. So, for example, what you would do would be someone would click on a button and you would have attached a function to that button so that when somebody clicks on it, this function is called. And there's lots of ways of doing that, but that's a common thing. It's also commonly used in network programming. When a message comes in, this happens, or asynchronous programming, when this task finishes, call this function. So, very common thing in computer programming. But the important thing about functions in pretty much every language, Python is looser than many, but even in Python, is you cannot call the function with the wrong number of parameters. So if I call wait and print with just a message, spell it, it complains because I am missing one required positional argument. Now, Python does give me a lot of tools for allowing me to do that. I could give parameters default values, which they take on if I don't pass them. I can have keyword values. I can do various things. And a lot of other languages offer this as well, though some, notably C, just plain don't. But what would happen if I wanted somewhere deep down in my code to have this wait and print function be called? And what about if the place where I knew how long it had to wait for wasn't the place where it was actually called? Because in this caller function here, I've put in exactly what's going to be called. It's going to be called waiting 2 seconds with hello world. But what about if it was something where what I actually wanted here was, let me redefine this caller. Takes a function. Okay, and it calls that. Match case. And it won't work again because of a missing required argument. So the point is, I can only pass it in a function that it calls in here with the right number of arguments. And now, in this definition, it's only trying to call it with 1. So if, for example, and that would be usually a case of most cases where you call it, most callbacks really do only take 1 parameter. This one here that I'm doing is somehow special. It has this wait for 2 seconds element, wait for some seconds element. So what could I do if I wanted to do that? Well, I could write another function. Wait to and print. Oops. Takes a message, which always does time.sleep2 and prints the message. And I can now do my caller to call wait to and print, and that waits 2 seconds and prints my message. But at this point, the number of functions you've got are actually running almost out of control, because for every different amount of time I'd want to wait, I'd have to write a new function. So what you really want to do, in some senses, is encapsulate the idea of, I want to be able to take my wait and print function, and I want to be able to bind one of the values, that wait parameter, the how long I should sleep for, and just create a new function that only takes 1 parameter, but internally has captured a value when you create the new function of how long it should wait for. So, show how to do that. So the first thing you can do is something very like this wait to and print that I wrote, but instead of doing re-implementing wait and print, I will actually just call in here wait and print. Okay, and once again, that'll work perfectly. But now, if I change the implementation of wait and print, I don't have to keep wait to and print up to date, which is good. I've already saved myself some work. I now have code reuse, which is extremely valuable. But I still have to, for every different amount of time I want to wait, create a new one of these functions. What I actually kind of want to do is write something that will create a function with that how long to wait for parameter bound to it, so that I don't have to manually write them all. And as it turns out, in some languages you can do that. Notably, you can do it here in Python, and I'll show briefly afterwards, you can do the same thing in C++ as well. So, in Python, what you do looks a bit strange, and this is well worth knowing because the idiom looks a bit weird. So I'm going to create a new function. I'm going to call wait bind. And wait bind is going to take 2 parameters, which is a wait for parameter and a function parameter. Okay. Now what I'm going to do looks mad if you're not already familiar with this, because I'm going to define another function inside, which I'm going to call bound. And the bound function is going to take just 1 parameter, which is the message. So this function looks like the type of function that my caller here expects. Okay, and inside bound, I'm going to call wait and print with wait for, which you'll remember is a parameter here to this outer function, and also message, which is a parameter to this inner function. Okay, and I now return bound. Now you'll notice here the indenting is actually sort of rather helpful here, because this line here is not part of this internal function, this sub-function bound. It's part of bind wait. So I am defining a function inside bind wait, and I am returning the function. And the interesting thing about the way Python works here is this wait for parameter is actually what's usually called captured. So if I call this, so I'll say func equals wait bind, wait for 2 seconds. Okay, and my second parameter is the function that I'm binding. Okay, and I can now call func with hello world, and it will wait 2 seconds and print hello world. And if I change that 2 there for a 1, it'll wait 1 second and print hello world. So effectively what I've done here is I've created a function, my wait bind, that creates functions, these bound functions that are returned. And this is possible in Python because in Python functions are what are called first class objects. So you don't just have one true canonical version of a function. A function is a free floating thing. It can be assigned to a variable, it can be redefined, it can be changed in various ways, it can be created. But the important thing of what's happened here is this wait for parameter is being captured by Python. So even though I'm using it here inside this inner function, even after returning from wait bind, because the fact that this line completes means it is returning from this outer function, this value of wait for is still kept, it's still remembered, and it's still there. So when I call the bound function, this func here that I get back, because I'm returning bound, when I call this returned function, it remembers the value that I put in here. And this is this binding idea, because I can now go back to my caller and I can call it with func, and it'll wait 1 second and print hello world. I can call my bind here again, 5 seconds, and I now have to wait 5 seconds, which feels like an eternity when you're trying to talk over it, and there it is, hello world. So effectively I have taken a function that should have 2 parameters, and I have automatically wrapped it in such a way that it now only has 1 parameter, so I can use it in places that expect functions that have only 1 parameter. Now obviously in one sense this is trivial. You can do it in literally any language because you can just create a function that calls. You can create a function that takes 1 parameter and calls a function that takes 2 parameters with one of those parameters pre-filled in that function, exactly like I did back up here. I can always do this in any language that has functions, which is essentially every language. But the advantage of this sort of approach is that I no longer have to manually create all those functions. I can just create them when I need them and store them and use them. Now in something like Python, that is in some senses unremarkable. Python is very well suited. It has, as I say, these functions as first-class objects. Functions can be created and they are not tied to one canonical implementation of a function, the way they are in a compiled language, the way they have to be in a compiled language. But as it turns out, you can do something extremely similar in C++. I'm not going to go into this in great detail because it is quite a complicated area. But the idea in C++ is one of 2 things. Now the older one is something which is called standard bind. So standard bind is something that has been in C++ since C++ 11, and you'll see it quite a lot, even though it's a bit ugly in various ways. So let's just do a quick example. Okay, so pretty much everything here is going to have to use the header functional, which is the part of C++ that includes functional style programming. Now, I will say a lot of this stuff, if you come from a functional programming language like Lisp, you will say, well, this stuff's obvious, everybody knows this, but it's actually much less common for people working in imperative programming languages like C, C++, Fortran, Python, whatever. But you can do it with greater or lesser degrees of elegance in all of them. So I'm going to create my main function, but first I'm going to create a demo function, which is going to be void. It's going to be very similar, which is going to take an int, and why not have a string? Oh, not string, string. I will also put in all the stuff that's needed for printing and for having strings. There we go. So we now have a function that takes an integer and a string. I could have it wait, but I'm getting fed up with waiting, so I'm just going to have it print the integer, and then a colon, and then the string, and then a new line. So, very simple function, just to demonstrate it will work. That. Okay. Okay, so I have to give my string a name, obviously. There we go. So, one hello world. That's exactly what I wanted. Now, let's imagine that what I want to do is I want to create a function that will always print the 1, but I can change the hello world. So, we'll call it bound. So, I will show in a bit how you would actually store these, but for the moment we'll use a very helpful C++ thing, which is auto. So I don't have to worry about the exact type of what I'm getting back. So I'm going to start by using standard bind. So standard bind I would use like this. The first thing that goes to standard bind is the function name that I'm binding, because the whole point is I'm trying to create a new function. So I need to know the old function that I'm wrapping, and then I'll put in the first value. And then this is where bind gets a bit awkward, because I then put in _1, which means the first parameter to the bound function goes here. So effectively what I'm saying here is I want to call the function demo with a fixed value 1, and then I'm left with one extra parameter, which is this 1 _1 here, and call this with that function, that parameter, as the second. So call demo, demo's first parameter is 1, and its second parameter is the first parameter to the bound function. Okay, so I compile that again. Right, yes. This is something I always forget. When you actually do this, there's such a long name that you always ignore it. So standard placeholders 1. So what you would usually do if you're actually using standard bind is using standard placeholders. I always forget when I demonstrate this. Okay, I can combine that, and I can compile it, and I get out 1 hello world. Okay, and I can put in a 5 instead, and I get 5 hello world. So exactly like in Python, I've created a new function called bound that calls my function demo in the background but always fixes one of the parameters to be a known parameter. And I could, change how that works. So if I wanted to bind the first parameter instead of the second, I would just switch them around like that, and this would now no longer take hello world, but would take, say, 42. Now I get 42 hello world. And I could indeed, if I wanted to, bind it right the way down to taking no parameters at all. And there we go. So I've done exactly the same thing. I've taken a function and I've changed what parameters it needs. So can I use the result of that absolutely anywhere I could use an original function having this reduced signature? And the answer is not quite. And the reason for that is that what standard bind returns isn't necessarily quite a normal function. What it actually will be returning is effectively something that, to be clearer, it is not actually quite guaranteed what will be returned. What is guaranteed is I could store it, I don't have to use this auto, in something which is a standard function object, which returns a function of the right type. And this void open brackets close brackets means a function that doesn't return anything and takes no parameters. So standard function is real magic. At some point in the future, it'll probably feature in one of our Inside the Black Box videos to show how it works, because it's really quite clever. But the thing is, so long as you can use these standard function objects, you can pass around the results of bound to anything. If you're a C programmer and using old style C function pointers, you can't, or at least you can't necessarily. But one of the immediate things that sort of comes up is, well, once you're talking about using standard function, there's a more modern feature of C++, which is called lambdas. Could you not use lambdas? Now, lambdas actually come in the same standard as standard bind, but they've become rather more popular since then, and also quite a lot more powerful. But at which point you can avoid some of this slightly nasty standard bind syntax with all those standard placeholder _1 things. What I could just do is write a lambda, which takes, I'll make one that takes nothing, and that just calls demo 128 hi there. Okay, and that is a valid lambda. And will that work? Should do, and it does. It's exactly the same. Now, in some senses, of course, this version is like the other version I showed in Python. I've literally just written a function that calls the inner function. But lambdas are deliberately designed to be lightweight. They're deliberately designed to be quick and easy to write. And it's quite a convenient way of doing it. And equally, you can do tricks with lambdas that you couldn't do with standard bind. So, for example, if I define int I is 24 here. Now, in here, this section in the square brackets is what's called the capture section. As I said, in Python, you have this idea of capturing variables. So even after something has been and gone, you still retain a value. Now, I could just put in here I, and then I put the I there, and it works. I get my 24. And the notable thing there is if I change I here to 48 after I've created my bound function, it stays 24 because this capture has captured the value of I at this line. And that is very useful. Sometimes that's what you want. You want to say, I want to capture the value of this variable and use it in this function, remembering that value. But sometimes you don't. So if I put in here ampersand I, which is not here taking the a pointer to I, it's getting a reference to I now have 48. Because what this lambda here has done is it has captured a reference to this integer, and when I then change this integer here, the reference is automatically updated. So lambdas are extremely powerful in this sort of situation. You can't do the same thing with standard bind. That always captures by value, I believe. And that's basically it. So you can modify a function to have a different signature to the one it has by using these ideas of binding. So you can partially specialize a function and leave some parameters exposed. You can completely remove all parameters. You can actually add parameters using much the same kind of approach, though not with standard. Actually, I think you can even with standard bind. You can add parameters and... No, you can't with standard bind because it calls a single function. But with these lambdas, you could add an extra parameter, do something else with it, and then call the function. And similarly, in Python, you can do the same sort of thing. And this is very useful. As I mentioned, this is quite often connected with callback functions. You have a function which you need to have a specific signature because it's going to be called with that specific signature, but at some other point in the code, you know some other values that you want to have attached to it. And we also did a video on what we call tramp data, and that's a term that's generally used, which is data that is passed around through far more of the code than when it's needed. And this sort of approach of binding data to a function call is one way of avoiding having to pass that tramp data around. So as I say, that's a very quick tour through all this area of binding values to functions to make other functions with different signatures. And we really will, I think, come back to standard function and what it actually does behind the scenes, because it's really quite interesting.